Hi there, this is Dr. Satish Kumar. I welcome you all to my video lecture. In this video lecture, we will see an introduction to a few material parameters which we use with behavior characteristic study. So this is a part of ENG336 Advanced Mechanical Principles Pearson Level 5 Higher National Diploma Unit. Now, stress. We often, whenever we study mechanical engineering, the most often used term is stress and strain. What is stress? Stress refers to internal resistance developed in a body, internal resistance developed in a body against the applied load. So this is referred to as stress. So the formula for stress is, it is often represented by sigma load per cross sectional area. Okay, load per cross sectional area. If I take a body, imagine I am applying a load, then this cross sectional area is what I refer here. Okay, so its unit is Newton per meter square or Newton per mm square. Okay, or sometimes it is expressed in Newton per mm square. So when I say stress, it is of two parts. One is we have normal stress, which is what I expressed here, then something called as shear stress. So shear stress is when the load is applied along the plane of the body, for example towards the plane of a body, then it will experience shear stress. For example, imagine a body here, okay. So imagine here the load is applied normal to the plane. Okay, here the load is applied along the plane. So the type of stress experienced by this body is called as shear stress, and the type of stress experienced by this body is normal stress. Okay, fine. So next, the most important term we usually study is, I'll just write this as stress, strain. Strain refers to the formula itself refers to change in volume to original, change in dimension to original dimension. So this is called a strain, and it has no unit. Okay, so if I measure the strain along the linear direction, for example, let me take a two-dimensional body. Imagine I apply a load P, then the increase in the length, okay, that I call it as linear strain. Okay, so this is my linear strain. So that is change in length by original length. So you can also refer like this. If the change in the dimension is along the application of the load, then I call it as a linear strain. I have something called as a lateral strain, where this refers to the change in dimension which is normal to the applied load. Okay, just normal to the applied load. Here in our case I can refer this as width, or I can refer it as height to original dimension okay. Now whenever I apply a load, when I say there is an increase in length, if you properly notice, the height of the body will have reduced, okay. So the change in the height, okay, this is my original height and this is my deformed shape, so this is my deformed height. So if I measure this, then the change in the dimension to the original dimension is called as lateral strain. And the most important factor, Poisson's ratio. Poisson's ratio is defined as negative of lateral strain by linear strain, okay. So often it is denoted by nu or mu in some cases, in some textbooks. So this is what stress and strain is about. Like as the stress is we consider as normal stress and shear stress, strain is also considered as normal strain and shear strain. The normal strain is what you study here, okay, the change in dimension by original dimension. When it comes to shear strain, when I apply a shear load, just like in this case, okay, I will explain with the two-dimensional load, that is much better and easy to understand. If I apply shear stress like this, then the body may deform like this, okay. Shear strain refers to angular deformation upon applied shear stress. So when I apply a shear load, or when I apply a shear load, the body tends to deform in its shape. So the deformation in the shape observed, the angular deformation in the shape observed is called as shear strain, okay. So these are all the important fundamentals that one should know before studying advanced mechanical principles. See you all in the next video. Thank you.